Hi everybody, this is Mr. Fowler, and this is podcast 9.4 for Excel, oops, no it's not 4, it's 9.3, and 9.2 for prep. So define differentiate between G, H, and S. If delta H and delta S go up or down given a chemical reaction, relate spontaneity to delta G, and determine spontaneity given G or H and S separately. So hop right to it. Spontaneity tells if a reaction will happen or not. It does not tell you how fast. Ice spontaneously melts at 0.01 degrees Celsius, but not quickly. So, will a reaction happen or not? Spontaneous means yes, it will happen. Okay? Gibbs free energy, delta G, has the units of kilojoules. Basically, it tells us spontaneity. If delta G is negative, the reaction is spontaneous. If delta G is positive, the reaction is non-spontaneous, and the reverse reaction occurs. So, here's a hill with a ball, or a BB-8. Okay? Will a ball spontaneously roll up a hill? Not spontaneously. You can make it go up there, right? And you can make it up there if you put energy into it. So the reverse is spontaneous. Rolling down a hill is spontaneous because it happens without extra energy, right? Does that make sense? I hope. So Gibbs free energy, right? This free energy means energy released to do work. But you need to know negative, spontaneous, positive, non-spontaneous. Enthalpy is delta H. The units are kilojoules for this too. Basically, this is internal heat energy. So heat energy. Whoops. If it is positive, then so that means delta H is positive. If the heat term would go on the left, that means A plus B plus heat yields D plus F. Then it would be endothermic. So I say pull-endo. If delta H is positive, the heat term is on the left, it's endothermic. We've seen this before. We've seen this a handful of times. Yay. Nature favors a decrease in enthalpy. Remember, low energy good. Remember when we had our energy diagrams? Woo, this was good. Woohoo, because this is lower energy. Entropy is S. The units are joules per Kelvin. Chaos. Chaos is what entropy is. So I think chaos is disorder. If you have more gases, you have more chaos. Okay? And liquid has more chaos than solid. But really, gases drive the whole thing. So if I said, oh no, I dropped 2 ice cubes and I have to pick them up and put them into my glass. Okay. Doink. Doink. Easy. Now what if I dropped that, what if I spilled that much liquid water? Well, I could get a rag and soak it up, wring it out, and put it in the glass. Now what if I had steam? I don't know how to draw steam. Could I get it all back in the glass? No, because the chaos is so much, its scatterability, its disorder is so much. More particles makes more chaos. Chaos is a mess. If you have more volume for gases, it's more chaos, more of a mess. Hotter is more chaos, more of a mess, and the reason why hotter is more chaotic is that it scrambles, or you can say shuffles more. Okay. And in the video that we watched, there was a guy who said, oh, you've got a salad. Is it a salad? You keep tossing the salad. Does it ever go back to its original thing? No. Nature favors an increase in enthalpy. Delta G equals delta H minus T delta S. The math part is gone, so we don't need to worry about that so much. Notice this was in joules. The other ones were kilojoules, so you don't need to worry about that so much. If delta G is negative, then the reaction is spontaneous, favored by nature. Temperature is in Kelvin, so it is always positive. Remember, 0 Kelvin is absolute 0. So there's no such thing as a negative Kelvin number. Okay? So weird unity things. Delta G equals delta H minus T delta S. If nature favors H and S, it will be spontaneous at all temperature. Remember, nature favors H when it is negative and S when it is positive. Okay? So nature favors delta H, nature favors delta H as negative, delta S is positive. Okay? If nature does not favor delta H and does not favor S, it is non-spontaneous. So this means it is spontaneous, and delta G is negative. And if you play with the math, you can see that too. If nature does not favor H and does not favor S, it is non-spontaneous for all temperatures. That means that delta H would be positive, an increase in energy. Nature doesn't like that. And S would be negative, which would be more ordered, and nature doesn't like that. This is non-spon, and delta G is positive. If it favors one or the other but not both, then it is temperature dependent. So that means if delta H is positive and delta S is positive, it is temperature dependent. And that means you can't tell. And if delta H is negative and delta S is negative, it's temperature dependent. It means you can't tell. You can't tell without doing the math. We can do math, but we're not going to. If delta G is 0, the reaction is at, well, why is that? All that stuff. It'll go in it, right? It does. If delta G is 0, the reaction is at equilibrium. Both reactions happen at the same rate. Water melts. Okay? So at equilibrium, see, water solid turns into water liquid. Okay? So this is an equilibrium reaction. Remember, water melts and freezes at the same temperature, right? So what is H's sign? To go from a solid to a liquid, it must absorb energy. What is S's sign? S is positive. Oh, come on. S is positive because a liquid has more disorder. So, and again, H was positive as well. What is G sign? It depends on the temperature. Okay. Now, is it favored at a high or a low temperature? So if I have delta G equals delta H minus T delta S, favored means is it's spontaneous, right? So if delta H is positive, I'm going to subtract a positive. If this temperature is high, makes delta G negative and spontaneous. So it's favored at a high temperature. Okay? Sulfur dioxide melts. Oops, why did I do this? H is 40 kilojoules per mole. Oh, I think I didn't mean to do this. S is 715 joules per mole Kelvin. What temperature does water start to spontaneously, not water, what temperature does SO2 spontaneously start to melt? That is the equilibrium. Delta G equals delta H minus T delta S. Delta G is 0 because it's at equilibrium. Delta H is 40 minus T, and then S is come back here. This is 40 minus T and 0.715 because I want these to be in the same unit. So this is 0.715 kilojoules. Okay, here we go again. We'll try it again. 40 minus T times 0.715. And my calculator's not around here, but I'll swing it over here. So negative 40, oops, come on back. Oh, you dirty dog. So I swing this around, negative 40 equals negative 0.715 T. So T equals negative 40 over negative 0.715. So whatever that answer is the temperature where it happens. That is it. Review. Know your definitions. You need to know what S is. You need to know what H is. You need to know what G is. Do math and change that unit. Phase changes are at G equals 0, and gases have the most entropy. That is it, Toodles.